This research investigates the connection between perception and production when learning to discriminate between unfamiliar sounds. It is commonly assumed that humans use the same neural mechanisms for recognizing a spoken sound and producing a sound. If this assumption is correct, when we get better at perceiving sounds, we should also get better at producing them, and vice versa.
Our research asks, do linguistic perception and production utilize the same neural processes? Does one get better at perceiving the difference between two sounds by producing them? By answering these questions, we hope to uncover the neural underpinnings of linguistic perception and production.
To answer these questions, 20 participants were trained on a new sound contrast over the course of 2 days. The new sound contrast contained dental retroflex sounds from Hindi and had 6 steps on the continuum from one sound to the other. The first 3 sounds on the continuum are dental sounds, which are made with contact between the tongue and the teeth. The last 3 sounds on the continuum are retroflex sounds, which are made with the tongue pointed towards the back of the mouth. The dental sound on one side of the continuum sounds like this. The retroflex sound on the other side of the continuum sounds like this. Most native English speakers cannot distinguish these sounds before training. Each day, subjects participated in a pre-test, a training period, and a post-test. Training, pre-tests, and post-tests consisted of ABX tasks where the participants heard 3 sounds. The first and the second sounds were distinct from each other. The third sound was either the first or the second sound replayed. The participant had to determine whether the third sound was the first or the second sound. During the training period, participants were told whether their selection was correct. During pre-test and post-test, the participants were not told whether their selection was correct. The experiment had 2 conditions. In the perception and production condition, subjects produced the sound during training after each ABX task. In the perception-only condition, subjects did not. Scores on pre-test and post-test were compared to determine how well subjects had learned the sound contrast.
In the results section, the graph on the right shows the day 1 pretest and day 2 post-test scores for the perception and production participants, and the graph on the left shows the day 1 pretest and day 2 post-test scores for the perception-only subjects. The blue lines represent the pretest scores, and the red lines represent the post-test scores. The y-axis on both graphs represents the percent of the participants' correct answers for the ABX tasks in the pretest and post-test. The x-axis on both graphs shows which sounds on the contrast continuum the subjects heard. The numbers 1 through 3 represent the category of dental sounds, and the numbers 4 through 6 represent the category of retroflex sounds. If the subjects successfully learn the sound contrast, we would expect to see a large peak in the middle of the plot where the categories of sounds are different. In the perception-only graph, the post-test scores are higher than the pre-test scores, which shows that the perception-only participants showed improvement in learning the sound contrast. Furthermore, we see a peak in the middle of the plot, which indicates robust learning. However, in the perception and production graph, the post-test scores are not higher than the pre-test scores, which shows that the perception and production participants did not learn the contrast as well as the perception-only participants.
Our research challenges traditional assumptions about linguistic perception and production by showing that the relationship between perceiving and producing new sounds is competitive. Our research reveals that producing new sounds while learning to discriminate between those sounds hinders perceptual learning. These results show that linguistic perception and production may not utilize the same neural mechanisms. This experiment informs second language teaching methods. Our results show that teachers should incorporate a curriculum that allows students to take breaks between learning to perceive and produce words and sounds. Understanding the relationship between linguistic perception and production is essential for optimizing second language teaching methods and for understanding how humans acquire language.